ZFS Dedupe? It's a feature that for years has come with a huge warning label, right? A super powerful tool, but one with a really dangerous reputation. But what if that's all about to change? There's this new thing called fast dedupe, and it might have completely flipped the script. So today, we're going to dig in and see if this beast has finally been tamed. You know the drill. You go on a forum, you ask about ZFS Dedupe, and what's the first thing you hear? Don't do it. Just don't. The community wisdom has been absolutely crystal clear for a long, long time. Turning it on is a one-way ticket to a world of performance pain, unless you are an absolute wizard with a very, very specific use case. It's always been that shiny feature you look at, but you know you're not supposed to touch. But what if that's not true anymore? That's the huge question we're tackling. See, there's this new feature, Fast Dedupe. iSystems, the folks behind TrueNAS, actually sponsored its development, and it's designed to solve the exact problems that gave dedupe that scary reputation in the first place. So you gotta wonder, is all that old advice now, well, obsolete? Okay, so to really get why fast dedupe is such a big deal, we gotta take a quick trip back in time. We need to understand why the old version was so, well, feared. Let's talk about the dangerous reputation of ZFS Dedupe. And here it is, the classic double-edged sword. On one side, you have this amazing promise of saving huge amounts of space. Super tempting, right? But the other side, oh man, the risks were massive. It needed an insane amount of RAM, and if you didn't have enough, your performance didn't just get slow, it fell off a cliff. But the absolute scariest part? It was irreversible. Once you flip that switch on a dataset, that's it. No going back. You were stuck with it, for better or, more likely, for worse. So how does this whole thing even work? I mean, what's going on under the hood? To really appreciate just how clever this new fast dedupe solution is, we need to do a quick rundown on how deduplication actually works in ZFS. Okay, it really boils down to two key things: data blocks and hashes. First, imagine ZFS taking all your files and just chopping them up into these fixed-sized chunks. We call them data blocks. Then, for every single one of those blocks, it creates a hash. Think of a hash as a unique digital fingerprint. So you can have this huge 1 megabyte block of data, but its fingerprint is just this tiny little identifier, only a few dozen bytes long. Pretty cool, right? So where do all these digital fingerprints live? Well, they're all stored in a special place called the duplication table, or DDT for short. The best way to think about it is like a massive library catalog for your entire ZFS pool. Every time you try to write a new block of data, ZFS calculates its fingerprint, looks it up in the catalog, and asks, hey, have I seen this one before? If the answer is yes, ZFS doesn't waste space writing it again. It just creates a little pointer to the block that's already there. Smart. And right here, this is where all the problems started. For dedupe to be fast, like at all usable, that entire massive library catalog, the DDT, had to fit inside your system's RAM. The second that table got too big for your RAM, bam, performance would just fall off a cliff. The system would be forced to constantly check the slow hard drives for that catalog, and your storage speeds would just collapse. It was a total disaster. So that was the old way. How does fast dedupe come in and save the day? Well, it's pretty brilliant, actually. It introduces two huge changes that go right after the old system's biggest weak spots: the way it writes hashes and the way it manages that DDT over the long haul. All right, let's talk about change number one, writing the hashes. The old way was, frankly, terrible. For every new block, it was one tiny, random write to disk. Super inefficient. Fast dedupe is way, way smarter about this. It gathers up a whole bunch of new hashes, groups them together, and writes them all in one big, clean, efficient go. This completely changes the I/O pattern. It's a massive speed boost, and if you're running on spinning mechanical hard drives, the difference is night and day. The second fix is maybe even more important. It's called pruning the DDT. Basically, the system can now look at that giant catalog and find fingerprints for old data blocks that were unique, meaning they were never duplicated, and it just removes them. It cleans them out. This is the fix for that giant RAM problem. You're constantly cleaning house, getting rid of old, useless entries, and that keeps the DDT from growing out of control. It stays small, it stays fast, and most importantly, it stays in your RAM where it belongs. Okay, so the tech is way better. That's awesome. But, and this is a big but, it doesn't mean you should just go turn it on for everything. The basic rules of what kind of data actually works well with dedupe, those haven't changed a bit. So let's talk about when you should actually use this thing. Let's put a perfect example right next to a terrible one. Think about VM backups. You back up a virtual machine today, and you back it up tomorrow. The vast majority of those files, the operating system, the applications, they're going to be identical. That's the perfect use case. Dedupe loves that. Now think about something like a daily SQL database dump. You might think, hey, it's mostly the same data, but it's not. If you add even one new row of data near the top of that file, it can shift everything else down. All of a sudden, none of the following blocks are identical to the ones from yesterday's backup. And just like that, dedupe is useless. And this quote really nails it. This is the absolute core concept you have to understand. For deduplication to work, the data can't just be conceptually the same. It has to be bit for bit, 100%, binarily identical. If there's even one tiny bit of difference, ZFS won't see it as a duplicate. You get all of the performance overhead and absolutely zero of the space savings. It has to be a perfect match. But when you get it right, oh, the results are amazing. The source material gives this perfect real-world example. They had a bunch of VM backups that should have used 250 gigs of space, but with dedupe turned on, they only used 100 gigs. That's a 2.5x space saving, a massive win, and it's all because they picked the perfect kind of data for the job. All right, so you're thinking, hey, I've got the perfect use case for this. That's great, but hold on. Before you go flipping that switch, there are a few more really important things you need to know. Let's go over some final tips and some pretty critical caveats. First things first, and this is non-negotiable. Test it. Before you even think about turning this on for your important data, create a test data set, copy your stuff over, and see what kind of dedupe ratio you actually get. Second, use a large record size. This makes the DDT way smaller and more efficient, which is a huge win for performance. And finally, don't forget about compression. They're two different things. Remember that SQL dump that was terrible for dedupe? Well, it would probably compress down like crazy. Always use the right tool for the job. And just to be super specific on that last point, for something like VM backups, the recommendation is to use a 1 megabyte record size. Now, why is that so important? Well, it means for every full megabyte of data, the DDT only needs to keep track of one single fingerprint. Compare that to a tiny 4K record size. You're talking about something like 250 times fewer entries for the DDT to worry about. It's a massive efficiency gain. Okay, now for a big flashing red warning light. As of the time of the source material, there was a nasty bug in the TrueNAS scale user interface. The feature to prune the DDT by a certain number of days, it was broken. Instead of just pruning entries older than, say, 90 days, it was pruning all unique entries. Now, to be clear, this won't cause any data loss, but it completely defeats the purpose of the feature. The command line version worked fine, but if you're using the UI, be very careful with that button. And one last critical piece of info. Fast dedupe isn't backwards compatible in the way you might think. Because it changes how data is stored on the disk, you can't just take an old data set that already has dedupe turned on and magically upgrade it. It doesn't work that way. To get all these new benefits, you have to actually create a brand new data set from scratch. So that brings us all the way back to the beginning. Has ZFS Dedupe finally been tamed? You know, with these smarter writes, and especially with the ability to prune that DDT, it really seems like the biggest, scariest problems from the past have been solved. It's not this irreversible performance trap anymore. Now look, it's still a specialized tool. It's not for everything. But for the right workloads, for the first time in a long, long time, ZFS Dedupe feels like it's finally actually usable. So the real question is, what are you going to use it for?